Okay, so hello everyone. My name is Scott from the University of South Florida. We're going over quiz 6A. This is the 5 p.m. session. Oops. Just so you know, the gentlemen are in the back installing the air conditioning, so you may hear some hammering, sawing, and things of that nature. But, they're installing a new air conditioner, so, um, uh, we're going to tolerate the noise. Are there any questions before we begin? All right. So, let's see. Let me set everything up. So quiz 6A. Let's go ahead and get to it. We've got, let's see here. There we go. All right. So the first two was just to state these rules. Now, in the past, we've kind of gone back and forth on this, but we seem to have settled, in the last 3 semesters, we seem to have settled on just making you do these parts of it. So, of course, they are theorems and they do have conditions, right? So the conditions are, for the product rule, both f and g have to be differentiable at x. If that's so, then f times g is differentiable at x, and there's the derivative. And the same thing with the quotient rule, except there's also a second condition that g of x not equals 0. Now, as I said, before we've only made you write the two if it's asked, the highlighted portion if it's asked. But these things have turned into somewhat nasty true-false questions in the past about this. So let's suppose I have the question. So I encourage you to write the conditions. If they start requiring the conditions on the test, like they did last year, like they did 2 years ago, we'll warn you in advance. But if that happens, I'll warn you in advance. But for the most part, you don't have to write the conditions. However, I would encourage you to do it anyway, and here's why. These things can be really nasty or nice, depending on your perspective, true-false questions. So suppose I have an f that is not differentiable at 0, but g is. And then the true-false question says, then f times g is not differentiable at 0. And that's actually false. You can't conclude this, right? Consider f of x equals the absolute value of x and g of x equals 0. Well, then f times g of x equals 0, which has a perfectly nice derivative at 0. So just because one of the conditions fail doesn't mean that you can conclude anything about the conclusion. And right, suppose f is not differentiable at 0, but g is, then fg is differentiable at 0. That is also false, right? Then, here, fg of x equals the absolute value of x, which, as we know, is not differentiable at 0. It's got a nice little kink there. So the point is that if I don't meet the condition, I can't say anything for sure. This 1 to 5, how do we feel about that? These ideas that these things can become true-false questions. And the point is that if you wind up with this, you really can't determine anything. How do we feel about that idea? So, in terms of the quiz, if you only wrote the highlighted portion, then you're good. Okay, the highlighted portion is sufficient. However, I would start writing out the full conditions. And the reason why I would do it is because of true-false questions that look like this. So these true-false questions, they can get a bunch of them like this. So just watch out for this. I'm just saying, watch out for these landmines because they can happen. It can be that they try to throw one of these little curveballs at you. And if you can't meet one of the conditions of the theorem, you can't say anything. It could be, maybe not. You just can't say anything, right? The theorem is silent. You didn't meet its conditions. Okay. The two rabbits. The two rabbits are as follows. Was everyone able to find them in the notes? So everyone was able to find the proofs in the book. In the book, they are in section 2.3 in your textbook. I'm sorry, 2.4 in the textbook. There's no 2.3. Nope, 2.4. Okay, they're in 2.4 in your textbook. If you have a physical book, you'd notice it was on the Quotient Rule 1 was on page 109 in the textbook. It's the same proof. And the Product Rule 1 is the same proof I did in the notes. How do we feel about this idea that what I need to do is I have to memorize a rabbit? I don't need to memorize a whole proof. I can reconstruct the proof if I know the rabbit and a little bit of strategy. Right? There is a piece I have to memorize, but it's not the whole thing. That's the idea. Okay. Okay, so a rabbit. Let's define that then. If you don't understand what a rabbit is. A rabbit is something tricky that it usually either it's something I add that equals 0 or something I multiply that equals 1, right? So in both of these cases, I'm adding to the top when I do the proof. So I get to this point in the proof for the product rule where I've got equals and then I've got limit as h goes to 0 of f of x plus h g of x plus h minus f of x g of x all over h. And then I'm stuck. And then I add this little rabbit in here and I say the limit as h goes to 0 of f of x plus h g of x plus h. And here's the rabbit step, minus f of x plus h, g of x. I don't have enough room. Plus f of x plus h, g of x. Oops. Minus f of x, g of x. And because I added that rabbit, I can now factor the whole thing. Right? So it's this little, this right here adds up to 0. So I can do it. It's legitimate. Okay? So a rabbit is basically a trick. I'm adding a 0 or I'm multiplying by a 1. I'm pulling something out of thin air. But I can always add 0 and I can always multiply by 1. Okay, does that make you feel a little bit better? That's what a rabbit is. All right. The quotient rule definition, it's in the notes page. If you go to the... If you go to Files and you go to Class Notes, it's right here. Let me pull this up. So if you go to Files and you go to Class Notes, you'll come down here to the bottom and you'll see Proving Product Rule as one of the notes things here. You've got a whole bunch of notes. There's the definitions you want. There's the proof for the product rule with the rabbit highlighted. And here's the strategy, and you were supposed to use this strategy to create it. And if you have trouble, that proof is actually in the book. And I've already pointed out where it is. Any other questions about that? Okay. All right. Well, let's do one of these. And I don't know if they're going to show up on the test. So last semester before, all of those tests you've had either prove the product rule or prove the quotient rule, or an option to choose which one you wanted to prove. I don't know what it's going to look like this semester. We have a new coordinator. I don't know how she feels about the proofs. I don't know if, because we're doing online, we change it to a whole bunch of true false. I just don't know what's going to happen. But in the past, you have had to repeat a memorized proof on a test. Okay. All right, so I'm going to compute this derivative here. So what I'm going to do is I'm going to do d alpha, sorry, the derivative with respect to alpha, e to the alpha, ln of alpha. Now, whether or not you want to do this, I would highly recommend you do it whenever you use product, quotient, and chain rules, is write it out. Whether or not, I'll mark off points for you on the quiz if you don't. I don't know what the test rubric's going to look like. But even if it wasn't, anytime you deal with e to the x, I would write out the derivative step. Because it is so easy to mess that up. Because it is its own derivative. So you lose track of, wait, which one did I take the derivative of, etc. So I would always write it out anyway. I would write out anything to deal with e to the x. So this is e to the alpha, the derivative of the first times the second, plus the first times the derivative of the second. All right. Now I do this. This is e to the alpha, ln of alpha, plus e to the alpha times 1 over alpha. Stop there. Okay, just stop. You're done. All right. So how do we feel about that one, 1 to 5 there? So let's see. Now I can do that. 1 to 5, how do we feel about that question? Okay. All right. This one was a little trickier. What is f prime of 4 and how can you tell? Well, I come over here to 4 right there. Now, f prime of 4. Well, I go 1 over 2 over 2 up. Rise over run. I can do right there. So f prime of 4 equals 1. Alternatives. If I wanted to actually say something nice, I say, okay, well, it's a straight line. Okay, and then I do, f of 6 minus f of 2 all over 6 minus 2 equals slope equals that equals f of 6 is 4, f of 2 is 0. 6 minus 2, that's 4 this week, and this week only, equals 1. You could have said that. Okay, you could have said anything. You can't say anything, but something along those lines. Okay. G prime of 4. Well, G prime of 4 equals 0. And I can tell by the slope of the conveniently placed tangent line. If you've had calculus before, you will know that you could have also said, or I could say local min. It should be a local smooth min. Or just a min. Okay, so any of those things would have worked. G prime of 4 equals 0. And I can tell by the nice little slope. I should have said G prime of 4 equals 0. All I said was G prime of 4. And I lost the comma. There it goes. Okay. You could have done a whole bunch of things. You could have used point the 2.0, found the gradient. There's drill noises in the background. As I said, the people installing the air conditioning have priority over this. Sorry, guys. Okay, so computing f prime of fg prime of 4. Okay, here's what I would do. And you don't have to do this, but this is what I would do. First thing I'm going to do, I'm going to write all my points. Okay? I am going to write f prime of 4 equals 1. G prime of 4 equals 0. F of 4 equals 2. And F and G of 4 equals -4. All right, I would do that first. Because if you mess up, right, on somewhere else and you miscopied that, it's easy to identify where the error was. And you have your data close to you. So that's just what I would do. Your results may vary. Next thing I am going to write is actually what's going to happen. I'm going to write out the product rule. FG prime of 4 equals F prime of 4 times G of 4 plus F of 4 G prime of 4. I'm actually going to write out what I'm going to do. Then I'm going to make the substitutions. This one's 1. This one right here is -4. I'll be careful with him. Plus F of 4, which is 2. And G prime of 4, which is 0. Now, the reason why I'm going to write this out, well, first of all, you have to in my class. But even if you didn't have to, I would write this out. Because then it's obvious. If you mess up this later, you knew it was supposed to be F prime of 4 times G of 4. And then you made a bad substitution off your list. Oops. You know, you get minus 0.5 instead of -4. Because it's obvious that you made a mistake. But that you knew what you were doing, you just made a copy error. The other reason is if I accidentally put a minus sign here coming down, I actually had the times, and then, you know, I messed it up when I came back, and, you know, I got distracted, you know. I went, squirrel, you know, and got distracted. So we don't want to do that. Now I'll come through and I'll actually evaluate plus 0, which equals -4 this week. Okay. On the next one, I'm going to do the exact same thing as I did before. Of course, it's a computer, so I'm going to do it this way. Oops. And I'm just going to write it out. So F over G prime of 4 equals F prime of 4 times G of 4 minus F of 4 G prime of 4 all over G of 4 squared. And then I'm just going to do that again. So this will be 1 times -4 minus 2 times 0 all over -4 squared, which is going to be, this nice term here is -4 over -4 squared. I'm going to lose one of those there. Oops, not that one. And that is going to be -1 over -4 squared, which is conveniently 1. I'm sorry, not -4 squared, just over -4, which is going to be 1 over 4. All right. So how do we feel about that one, 1 to 5? A lot of pieces there. You guys were having a little bit of trouble here. I got a lot of emails about that, so I went ahead and made a little video on how to do them if you just had the numbers. Oh, and beware, on these quotient rule problems, D and E is a valid answer. Could be an answer. Right? If I had this, if I had set it up so that G of 4 equaled 0, that could have been it. So it's a common thing to do these where either the G prime is 0 or the G is 0, and see if you catch which one is the important condition. So it's a kind of mean way to make to make a question, to make a small mistake ding you 4 points. So watch out for that. All right. Any questions? I'm talking to you about mean things that test makers can do because I'm not the one making the test. So, okay. So, I'm going to talk a little bit about the problem set because the problem set, we're a little bit behind where we were supposed to be when we did this problem set because I did the whole thing. I took a day to do all of the power rule and stuff. So we're kind of a class behind, and the problem set's meant to come right after the lecture on chain rule. For this week. So the problem set is, we're just a little bit behind where the problem set is. So I'm going to go over the first part of the problem set together. All right. Because it was a disaster this morning. So, yes, it stinks that you guys have to take the quizzes, in the morning, because there's a morning class. But on the other hand, they didn't get very far in the problem set because I hadn't gone over part of it. And you guys are about to. Okay. So the problem set is set up like this. So what I want to do is I want to take this equation here, and then I shouldn't give away, although it's now given away. So everyone grab your problem sets, and we'll talk about the problem set real fast. So what I'm going to do is I'm going to set this up. I'm going to ask you to draw the equation. Now I want to compute the equation for that tangent line. So I need the slope, which means I need the chain rule. Okay? So let's talk about the chain rule real fast. The chain rule looks like this. And at 7 o'clock this evening, I will be going over the chain rule tons and tons and tons. But this is how the chain rule works. I've got something that goes from X to U to Y. Right? X is going to go on a journey. In your book, this is F here, and this is G. So I'll try to start to do them right. And I've got a chain of functions. I've got to go from X to U to V. I'm sorry, X to U to Y. So let's give an example. Okay, and the example is that f of x equal sine x squared. I should probably do a different one than the one I did this morning, but I'll do the same one. Now, the chain rule says the following. The chain rule says d over dx of f of u equals, now notice this is different than this. X and u were different. Okay, so this equals the derivative with respect to u, this is the chain, of f of u times the derivative with respect to x of u. Now, other ways to write it are dy over dx equals dy over du times du over dx. So if you're treating these like fractions, you can actually, if you're thinking about them in fractions, they're not actually fractions, but if you think about them in terms of fractions of nudges, changes, little nudges, these t du's, you could think of them as canceling, right? So it works kind of like a fraction. That's what the chain rule says. All right, let me give you the example here. So my example is the f of sine of x squared. Okay? What I'm going to do is I'm going to make this the u. All right, so here's what I'm going to do. I'm going to do d over dx of sine x squared. And again, I'm making this right here the u. Equals d over du sine of u times d over dx of u. And that's the chain. All right, that's going to equal here. The derivative with respect to u of sine of u is cosine of u. Now this right here becomes my baggage. Times the derivative with respect to x of x squared, because that was u. Which equals the cosine of u times 2x. Now, this is my baggage, right? My fiance, well, she didn't leave me at the altar, but she left me holding honeymoon tickets. So I have baggage that I have to carry. That's my baggage. I don't have to deal with her anymore, but I have baggage. In this case, it was, rather nice baggage because it was expensive luggage that I had to return as a gift. Anyway, so I have to do this. I just have to carry my baggage and then remember to carry your baggage. Then, because I made up u, I need to sub it back in. And that's it. That's the final answer. All right, so how do we feel about that 1 to 5? And as I said, I will be going over this a lot, but because I didn't have a chance to get to it, because I spent extra time going over the algebra of, of all of the power rule stuff, which was very appropriate, I didn't have a chance to get to this. So, yeah. So, we need to do it before we do the problem set. Okay. All right. So, if we look again at the problem set, that's the chain rule. And as I said, we will be going over that again and again and again tonight. I'll be do a lot more example of those. Okay, so now let's look at this here. I want to compute the equation of the tangent line. So I want m when x equals the square root of 1 over 2 and y equals the square root of 1 over 2. Okay, so is everyone on board with that I need to find that? Okay. All right. So what I'm going to do is I've got, this is y, and I need dy over dx. Now, when x equals the square root of 1/2. So, and I didn't leave enough room because I'm a horrible person when I did this. And so what I'm going to do is I'm going to draw this out. So what I'm going to have is y is going to equal 1 minus x squared to the 1/2, right? That's what I got when I made the equation happen. So dy over dx, I'm going to call 1 minus x squared u. And I'm going to have the derivative with respect to u of u to the 1/2 times the derivative with respect to u of, I'll just write chain rule here. Times the derivative with respect to x of the u. So when I do the power rule here, so here I had an x, here I've got a u now. And the point is that the chain rule is the thing that allows me to change the variable by which I'm differentiating. So what I'm going to do is I'm going to pull the 1/2 in front, and then I'm going to have u to the negative 1/2 times d over dx of this, which is going to be 1/2 u to the negative 1/2 times, and then the derivative of this is negative 2x. Yes, I should have put the 0 there. Okay, so these this 2 here and that 2 there are going to cancel. And I am going to simplify this a bit, okay, because it's going to make these numbers work out nicely. Now when I plug in dy over dx when x equals the square root of 1/2, if I plug in the square root of 1/2, I get this negative square root of 1 over 2 over the square root of 1 minus the square root of 1 over 2 squared. Well, that's convenient because those terms, that's 1 minus 1/2, which becomes negative 1 square root of 1/2 over square root of 1/2, and that's negative 1. So when I plug it back in, this becomes the equation of my tangent line. And if I want to make it neat, I get y equals negative x plus square root of 2. But this was the answer I wanted. And yes, I want you to figure out that work, but I don't need you to do it exactly right now because I don't want it to take you forever. What's it asking me for? We seem to have multiple clipboards now. Okay. It's probably a Windows update that I didn't read the change logs for, right? Okay, so how do we feel about that? Getting that tangent line. Okay. So go ahead. What we're going to do now is we're going to break into groups and we're going to finish it. I just didn't want you guys stuck on this one, which took forever because it's got a chain rule in it. There is another chain rule part of that problem that you'll have to talk about. Oops, it's not on that page, which is the next one when you talk about F, but that's fine. So go ahead, break out into groups. If you're in Discord, you can get into Discord. That's awesome. If you're in Blackboard Collaborate Ultra, and remember to stay, if you're doing something else like a group me or whatever, make sure that if you're not in the official Discord, make sure you stay in Blackboard Collaborate Ultra somewhere, so that I can get your, so I can make sure I hit your attendance. So let's see. All right. Are there any other questions?